Good day, my name is Dauda Mustafa, and I will be modeling and simulating a vibrating test bench which I use for my final year undergraduate project. It consists of a DC motor, an asymmetrical mass, and a top plate for simplicity. The DC motor. The DC motor was modeled using various parameters which describes the behavior of a DC motor, which includes the LA, RA, KE, KT, J, and B, among others. Using these various parameters, I was able to simulate and get the behavior of the DC motor from the mathematical model. The DC motor was modeled and converted to a max block for scalability and easy access. Using the max block, any user can edit the various parameters in which the DC motor behavior depends upon. Next, the asymmetrical mass. The asymmetrical mass is to cause imbalance in the shaft of the DC motor, which in turn will cause the vibration that causes the bench to vibrate. From putting an asymmetrical mass on the shaft of the motor, we were able to use the angular position of the shaft to model the way the system will behave when the rotation begins. Similarly, a max block was used. The signal from this asymmetrical mass is logged to the go-to block, and from the go-to block to the from block and to the scope block for readability. The values that the max depend on are the bearing mass and the offsetting radius, which causes vibration. Next was the top plate. The top plate is simply a mass spring damper system, which consists of 4 springs that are underneath the plate. These 4 springs are connected in parallel, therefore the mathematical formula will be minus 4k, simply. These various parameters are modeled using the mathematical model of a spring damper system, and similarly a max block was used to show the parameters and easy editability and scalability of the system. The system should be able to answer the following questions. What will happen if mass is kept constant and speed is varied? What will happen if speed is kept constant and mass is varied? We used a table to describe this, whereby voltage is kept constant and mass is varied from 2 to 6 in steps of 2. Next, the mass is kept constant 6 kg, input voltage in steps of 5 from 5. Next, the system will be simulated, whereby a controller using the input voltage and the mass, keeping voltage at constant and mass varies, starting with 2 kg mass. The RMS and the frequency was saved for the velocity and the displacement of the system. Next, the amplitude, the force amplitude, the RMS and the frequency was also observed and saved. Next, moving on, we scaled the mass to become 4, and keeping the voltage constant, we ran the simulation and observed the velocity and the displacement of the system. Seeing the velocity and the displacement of the system, the RMS value and the frequency was also observed and saved. The amplitude of force vibration was also observed, the RMS value and the frequency being saved. Next, we move the mass to become 6 kg while keeping the input voltage constant at 10 volts. Seeing the velocity and the displacement, the RMS value and the frequency of the system was saved. Next, the force amplitude was also observed, the RMS value and the frequency being observed and saved. Next, we will move to the second experiment, which is to vary the input voltage while keeping the mass constant. According to the second experiment, the mass will be kept constant at 6 kg. 6 kg, the mass will be kept constant while varying the input voltage in the steps of 5 from 5 to 15. Starting from 5 volts, the system was run and the mass 6 kg kept constant. The RMS value and the frequency of the velocity and displacement of the system was observed. Similarly, RMS value and the frequency of the amplitude of force was observed. Moving the input voltage to 10 volts, the system was observed as well, which is the velocity and the displacement of the system, the RMS value and the frequency being observed. The force amplitude of the system was similarly observed, the RMS value and the frequency being saved. Lastly, moving to 15 volts while keeping the mass 6 kg constant, the velocity and the displacement, the RMS values of the velocity and the displacement of the system was observed. Opening the scope blocks, we visualize them. Next, opening the force